Hi guys, what I'm going to be going over today is how and when to use integration by parts. You want to use integration by parts basically when you have the product of two functions and you want to take the integral of that. You can't normally do that without some sort of trick, and that trick we'll use is this formula here. The first thing we want to know how to do is which function we want to set to be u. There's a trick to this too. It's called the Lie rule. And basically, this is the order of priority of the functions that you want to choose to be u. The first is logarithmic functions, then inverse trig functions, algebraic expressions, trigonometric functions, and then finally exponential functions. You want to avoid choosing exponential functions as your u at all possible. Okay, so suppose we want to take the integral of e to the x times x. Then what we'll want to choose as our u is the algebraic expression x. So we'll choose that as u, and then the remaining part will be our dv. So what this comes out to be is then u times v, so it's u times the integral of e to the x, which is just e to the x. This is x, sorry, not u. Minus the integral of e to the x times the derivative of x, which is just dx. So now taking the integral of e to the x, we just have x e to the x minus e to the x. And we want to add on our constant of integration since it's an unbounded integral. So that's simply our final answer. You can simplify it to e to the x, x minus 1, if you want to. Integration by parts also works when you have a definite integral. So let's take a similar example. If you want to take the integral of y e to the negative y from x to infinity, then again we'll choose y as our u term, so e to the negative y becomes our dv term. So from the formula we have up here, you want u times v, so y times the integral of e to the negative y, which is negative e to the negative y, minus the integral of v du. So this becomes a plus e to the negative y, simply dy. Now we want to take the integral of this term here, so that becomes negative y e to the negative y minus e to the negative y. And this whole thing is bounded between x and infinity. So first we want to plug in infinity, so we just get 0 minus 0 minus x e to the negative x minus e to the negative x. So we'll simplify this. So we have, this is a negative, I'm sorry. So this will be x e to the negative x plus e to the negative x. So it simply becomes e to the negative x, x plus 1. That's our final answer. Yeah, so that's basically the lowdown on integration by parts. I'll be continuing to make more math videos if this is helpful to people and it becomes popular. I'm a third-year math major, so if you have any requests on anything in discrete math, calculus, statistics, probability, or any of the sort, I can probably help you out. So just, yeah, leave me a message. Talk to you guys later.